On this F150 with the 3.5 EcoBoost, P0183 points us toward the fuel rail temperature sensor circuit. In plain language, the PCM may be seeing that temperature circuit as open or shorted to voltage. The truck may show a check engine light, and depending on the fuel system state, it can have starting or drivability complaints. For this code, think in broad electrical terms first. Possible sensor circuit issue, connector trouble, harness damage, reference voltage or signal return problem, or a PCM input concern. Don't start by guessing at a part. Work the circuit. Before disconnecting any fuel tube or fuel system component, relieve fuel pressure. Fuel can stay under high pressure even with the engine off. Keep open flame, smoking materials, and personal electronic devices away from the work area. Be ready for spillage, clean fuel residue from the engine compartment, and use gloves and a face shield when disconnecting pressure lines, because fuel may still be trapped in the line. Start by checking which codes are actually present. If P0183 is the code you're chasing, this diagnostic direction moves into the fuel rail temperature circuit checks. If other fuel pressure or fuel temperature codes are present, check what they mean first and make sure the path you follow matches the code set in the truck. The shared fuel control test separates low-pressure sensor faults, rail pressure sensor faults, and fuel rail temperature faults before it gets into circuit testing. P0183 sets when the PCM detects the fuel rail temperature sensor circuit is open or shorted to voltage. So the logic is straightforward. First, make sure the reference voltage and signal return side are usable. Then check the fuel rail temperature signal circuit for an open, a short to ground, a short to voltage, and finally an intermittent fault. If the initial code check points into the low-pressure fuel sensor side, instead of the P0183 temperature side, the first move is still the same style of electrical check. With the ignition off, disconnect the applicable sensor connector, turn the ignition on, and on this 3.5 EcoBoost measure the reference and signal return voltage between C1073 pin 3 and C1073 pin 1. The expected reading is between 4.5V. If that is good, turn the ignition off, disconnect the PCM connector, and check the low-pressure circuit for an open between C173 pin 2 and C175E pin 77. That circuit should be less than 5 ohms. Then check for a short to ground at C173 pin 3. It should be greater than 10,000 ohms. After that, with the ignition on, check C173 pin 3 for a short to voltage. Any voltage present means the circuit has to be repaired before you keep going. A fuel pressure sensor PID value during ignition on, engine OFF, or ignition on, engine running, less than 0. 3 volt indicates a concern is present. If the low-pressure circuit checks pass and that branch calls for an intermittent check, reconnect the sensor and PCM, turn the ignition on, and monitor the FLP-VV PID. Tap on the sensor, wiggle the sensor connector, and work the harness in small sections from the sensor back to the PCM while watching for the concern to show up. Also inspect the connector for damage or corrosion. If that branch calls for a mechanical comparison, relieve fuel pressure. Connect a mechanical fuel pressure gauge. Disable the fuel pump, turn the ignition on, and compare the FLP PID to the gauge. Then pressurize the fuel system. Start the engine, let pressure stabilize, cycle the ignition off and back on, and compare the PID to the gauge again. The FLP PID values should be within 153 kPa 22 psi of the mechanical gauge readings. If the initial code check points into the fuel rail pressure sensor branch, disconnect the FRP sensor connector with the ignition off, turn the ignition on, and on this 3.5 EcoBoost check between C1073 pin 3 and C1073 pin 1. Again, the reference and signal return check should be between 4.5V. If that passes, turn the ignition off, disconnect the PCM connector, and check the FRP circuit between C1073 pin 2 and C175E pin 48. It should be less than 5 ohms. Then check C1073 pin 2 for a short to ground. it should be greater than 10,000 ohms. With the ignition on, check that same FRP circuit for a short to voltage. Any voltage present means repair the short, clear the PCM codes, and repeat the self-test. If no voltage is present, reconnect the PCM and FRP sensor, monitor the FRP-VV PID, tap the sensor, wiggle the connector, and work the harness while watching for an intermittent fault. A FRP sensor PID value during ignition on, engine OFF, or ignition on, engine running, less than 0. 3 volt indicates a concern is present. Also remember with the engine running, the FRP PID value may be 48-70 kPa, 7-10 psi, higher than a fuel pressure reading taken with a mechanical gauge. For the P0183 fuel rail temperature path, start at the fuel rail pressure temperature sensor. With the ignition off, disconnect the sensor connector. Turn the ignition on and check the reference voltage and signal return circuit. The expected reading is between 4, 5V5, 5V. If it is not in that range, stop this path and diagnose the reference voltage and signal return feed before moving deeper into the temperature signal circuit. If it is in range, continue to the FRT circuit checks. Use the correct connector information for the engine in front of you. Don't borrow pin numbers from a different engine layout. Next, with the ignition off, disconnect the PCM connector and check the fuel rail temperature circuit for continuity. The pass point for the open circuit check is resistance less than 5 ohms. If the circuit does not meet that, repair the open circuit, clear the PCM codes, and repeat the self-test. If the setup in front of you does not clearly match a continuity check, pause, recheck the earlier diagnostic path, and avoid guessing at the test connection. After the open circuit check passes, check the fuel rail temperature circuit for a short to ground. The circuit should show resistance greater than 10,000 ohms. If it does not, repair the short circuit, clear the PCM codes, and repeat the self-test. If that passes, turn the ignition on and check the same signal circuit for a short to voltage. Any voltage present means repair the short circuit, then clear codes and repeat the self-test. If no voltage is present, move on to the intermittent check. Again, if the short to voltage test setup is not clear for the engine you're testing, stop and recheck the path rather than guessing. Now reconnect the PCM connector and the fuel rail pressure temperature sensor connector. Turn the ignition on, access the PCM data, and monitor the FRT-VV PID. While watching that PID, tap on the sensor to simulate road shock, wiggle the sensor connector, and then wiggle, shake, and bend small sections of the harness while working from the sensor back toward the PCM. Inspect the connector for damage or corrosion. If the concern shows up, repair as necessary, clear the PCM codes, and repeat the self-test. If no concern shows up after the circuit checks have passed, the path calls for installing a new fuel rail pressure temperature sensor, then clearing the PCM codes and repeating the self-test. Keep verification separate from testing. After the repair is made, clear the PCM DTCs and repeat the self-test. The takeaway on P0183 is simple. Prove the circuit before condemning the sensor, and don't improvise connector checks when the setup is unclear. For more diagnostic training, visit stepdiagnostics.com.